Hello viewers, Mr. Nyati here, your presenter. This time around, commencing the physics, which is science paper 1, 5124/1, 2025 GCE, past paper. And I hope that as we begin in this series, you will be able to harvest that which is vitally important, especially for the preparation of examinations. That is talking to the grade 12 internals who are writing just a few weeks from now. And I want also to encourage every one of you, especially those also who are preparing for GCE next year, that the time is now. And if you feel like having a contact session with me that is to do with tuitions, online tuitions, please, you are free to basically go on the profile of the page or channel. You'll be able to see the phone number there and be able to WhatsApp me. May I suggest that you like this video, share this video, leave a comment in the comment section, and also subscribe to the YouTube channel called Barath Academy, and also on Facebook you can follow it, Barath Academy, and on YouTube, on TikTok I go by the name Nyati Bright. In this video I'm just going to strictly look at section A. And then in the next videos, like I did in science paper 2, I'll be able to do short videos. When I say short videos, I mean videos that are specifically targeting each question on section B and section C. So may we get started? We go straight into the question, and we open the question, and we should be able to answer this. Okay, so we get started, and in this section we are going to be able to answer all the questions. So we start with question 1. Question 1 says, a learner measured the diameter of a test tube and obtained 1.5 times 10 to the power negative 3 millimeters. What is the value obtained in a decimal form? A learner obtained the diameter of a test tube. So as this is being highlighted, you must be able to detect, sometimes as a learner, as a pupil, as a candidate that is attempting questions, you should think like a detector or a detective. So you should be able to detect what instrument was used to obtain the diameter of a test tube. Okay? So here you can either use a micrometer screw gauge, or you can use a vernier calipers. Okay, so you must be able to know if the diameter was specified internal or external. We could have been able to identify the instrument to say, but this is a vernier caliper or micrometer screw gauge. But in this case, it could be either of the two, vernier caliper or micrometer screw gauge. But that's just besides the point. You should be able to understand what the question is talking about. And then the question is, what is the value obtained in decimals? There are principles in physics that must be observed, and also there are tricks that you can use but still be able to obey the principle that is being highlighted. So in this case, you have this figure here, which is 1.5 by 10 to the power negative 3 millimeters. Now, as a student, as a candidate, you should be able to know what this means. Normally, I tell my students to say, whenever you see a negative power, okay, on a 10 or 10 as a base, you should be able to understand that there are basically 3 zeros before that number, in this case, this number. What do I mean? It simply means that, let me rewrite this, 1.5 times 10 to the power negative 3. So you are going to have 3 zeros. If you are to write this in decimal form, you are going to have 3 zeros, okay, which will be the first ones to start, and then the first zero, between the first and the second there should be a point. That's what it means, so that you're able to count 1, 2, 3, knowing in the back of your mind that the first zero and the second zero there is a point. And then you can write this number without a point this time around to say this is something like this. What are the units? Millimeters. Okay, so this is the answer that you'd be looking for. Let me give another example. If you have 1.45 times 10 to the power negative 5, let's say centimeters, how can you write this in decimal form? Okay, what is the negative power here? It is negative 5. You're just going to say that there are 5 zeros before 145. Remember that you're going to eliminate the point when you write it in decimal point, because the point will shift to the zero. So you're going to say 1, 2, 3, 4, 5, and then the first and the second you put your point, and then you write this number without a point at the end, 145 millimeters. This must take you back to this one if you want to write it in index notation, that is. So how can you convert this to this? You'll still be able to say 0.00, okay, 0145 can be converted like this. You count, because you are going to a non-zero digit, okay, which is 1 in this case, 4, 5. Then you are going to put the point between the first two non-zero digits that you are going to find. So in this case, you are going to say 1, 2, 3, 4, 5. So you're going to say 1.5, meaning that 1.45, meaning that you've ignored these zeros. You recognize them somewhere else. Multiplied by 10 to the power, how many times did you move? 1, 2, 3, 4, 5. You moved 5 times, and you are going this side. And because you are going this side, you put negative 5 millimeters. I hope this is making sense. So as you scan through for the answers, you'll be able to find that the answer, in this case, we're going to start. How many zeros? 1. How many zeros? 2. How many zeros? 3. The answer is C. So in this case, the answer for question 1 is C. We move on to question 2. Question 2 reads, a car traveling at 10 meters per second increases velocity to 30 meters per second in 5 seconds. What is its acceleration? Well, you must be able to solve this, okay? So, as usual, in physics, it's important to write the data that you've been given, okay? So, you're going to write the data. What data have you been given in this case? So, you realize that you have been given, in this question, you've been given velocity, okay? You have 2 of them. There is this one and this one. So between these two, one must represent the initial and the other one final. So which one is the initial? A car traveling at this. This is the first velocity that we've been told the car is traveling at, and then it increased to this one, which will act as final. So we're going to say initial is equal to this, final is equal to that, and then what are we being told? Time is there. What about acceleration? We are asked to find. So initial is 10 meter per second, final 30 meter per second. The time taken, we are told that this was done in 5 seconds, and the acceleration is not given. That is what we are asked to find. So what is the formula that we are supposed to use? Well, the formula for acceleration is, of course, change in velocity with time. What is the velocity? The final velocity, we have 30 meters per second minus 10 meters per second, all this divided by time, which is 5 seconds. And then we're going to have 30 minus 10, we're going to have 20 meters per second divided by 5 seconds. And what are we going to have? We're going to have 4 meters per second. Remember, it's like we're dividing second over second, second divided by second. Meter per second divided by second is like you're saying meter per second multiplied by 1 over second, which will be second squared. This is the answer. We move on to the next question. So before we move on to the next question, let's be able to identify the answer. The answer is A. Question 2, the answer is A. We move on to question 3. The displacement time graph shows the motion of a cyclist. Okay, the cyclist is moving in a specified direction. What was the speed of the cyclist at time 4 seconds? So be able to understand this. So you have this 5 and this 5. So you assume that at 4 seconds, the displacement must have been 4 meters. Okay, so there is that steady increase in display. In speed, because you'll be required to find either velocity and or speed from this displacement. Remember that displacement is distance in a specified direction, and when you are finding velocity, basically you say displacement divided by time taken. So now there is this steady increase which is shown here, and this is an assumption that at 1 second the distance, that the displacement that was covered was 1 meter, and so on and so forth. So at that point you'll be able to say speed would be equal to, because that's what the question is asking us to calculate. So speed would be equal to displacement over time. Remember, displacement in this case, it is 4 meters divided by 4 seconds, and this is going to give us 1.0 or 1 meter second. So in this case, the answer is A. Question 3, the answer is A, right? We move on to question 4. The energy output of a generator depends on its efficiency and the energy input. Okay? What set of values is correct? So here, this is a tricky question that if you are not careful, you may find yourself in a problematic dilemma whether to go with what you don't know or to guess the answer. But we need to be very careful, and we need to use our thinking. That's all. That is all about physics anyway. It's a science which basically tests mathematics experimentally. So here we are told that the energy output of a generator depends on its efficiency and the energy input, which set of values is correct. So now, under normal circumstances, you know that efficiency of a machine is equal to energy output over energy input multiplied by 100. Okay, so in this case we need to be able to come up with values that will be able to give us the efficiency that we want. So now pay attention that the efficiency here is not 100. Okay, is not calculated out of 100%, but it's only the values which are there, meaning that it is the quotient of the energy output being divided by the energy input without multiplying the quotient by 100. I hope you are getting what I mean. So in this case, we are going to eliminate 100 for now for us to be able to come up with the correct thing. So we're going to try all these values. Okay, so we begin with the first one. If we are to divide energy output is 25 divided by 50, that will not land us into having 0.1, because we're going to have 0. Somewhere 0.5. Do we have 0.5 here? No. So the A is wrong. We go to the other one. If we are to divide this, we say 6 divided by 30. What are we going to have? This will be 0.2. Do we have with the values which are corresponding to this 0.230? Yes. I would suggest B to be the answer. In fact, B is the answer. Because if we try the rest, we don't really reach at what we are talking about. Because if we try this, we are going to say 24 divided by 60, which is 0.4. Do we have 0.4? We have 0.6. This one, 30 divided by 120, This is 0 point, if we were to divide that, well, it will land us into 0.25. Do we have that? No. So the answer is B. So question 4, the answer is B. Move on to question 5. Question 5, the next page, reads, a crane lifts a 600 kg mass through a height of 12 meters in 18 seconds. What is the useful power output of the crane? So this one basically tells you that you need to collect some data from this question. What data can be collected from this question? Well, we have to find out. We are told that there is a crane which lifts a mass of 600. So we have mass which is equal to 600 kg. What else do we have? We have the height of 12 meters. Height of 12 meters. What else do we have? Time of 18 seconds. Time of 18 seconds. What are we told to calculate? We've been told to calculate power. What is power? We don't know. But whenever you have this, whenever you have height and mass, be advised that there is always force of gravity, which is 10 newtons per kg. All right. Then from there, can we be able to derive the formula? Oh yes. We're going to say power is equal to work done over time taken. But we also know that work done is equal to, but we know that work done is equal to mass times gravity times height. So where there is work done, we put this. So our power formula would be mgh over t. So that we can be able to replace or substitute 600 kgs multiplied by 10 newton per kg times 12 divided by time, which is 18 seconds. Let's punch that whole thing in a calculator. 600 multiplied by 10 multiplied by 12. What is the answer divided by 18? The answer is 4,000 watts. Remember, power is measured in watt. By the way, by definition, power is the rate at which work is done. So the answer for question 5 is B, 4,000. So question 5, the answer is B. We move on to question 6. Question 6 reads, by what process or processes is heat transferred from the sun to the surface of the moon? Well, we need to know that that is just in a place where there is completely a vacuum. That's a vacuum. Remember, space is a vacuum. So by what method is it transferred? Well, it is radiation only. So question 6, the answer is D, because it is radiation only. We move on to question 7. What happens to speed, wavelength, and frequency of water wave when it moves from the deeper end to shallower end? Well, we need to know that frequency remains the same because it depends entirely on the source, okay? But the speed, as the water begins to, as the wave begins to approach the shallower end, you need to realize that the speed reduces because the wave is interacting with the surface, and that creates some friction and thereby reducing the speed of the wave, and thereby also reducing the wavelength. So the answer here is C. Number 7, the answer is C. Move on to question 8. Water waves are produced in a ripple tank using a vibrator of frequency 6 Hz. Which of the following values of speed and wavelength could the waves have had? So this question is basically very, very tricky if you are not careful. Water waves were produced in a ripple tank using a vibrator of frequency 6 Hz. We've been given frequency. Which of the following values of speed and wavelength could the waves have had? So here, this is speed and wavelength. You've not been given frequency, but the frequency has been given in a question. So what are you going to do now to find the answer? You are going to use speed and wavelength to calculate for frequency, which the answer should be 6 Hz. Are you getting that? That's just how confusing sometimes this question may be, so that you do not see any answer at the end of the day you fail. It requires thinking, my dear colleagues, my dear learners. Pardon me. Yeah, there could be colleagues who are following this. Yeah. So now, what are we going to do? This is what we're going to do. We need to make sure that we use these values, okay? We use this and this to produce this. But remember, the formula for speed of wavelength of wave is basically frequency multiplied by lambda, which is wavelength. So if we want frequency to be the subject of the formula, we divide by wavelength on both sides, so that we have frequency being speed over lambda or wavelength. So we start with the ones which are here. 2 is speed, 2 centimeters per second. This is what we are going to use, because those are the units that have been given. So divided by 6, what are we getting? It will be 0. Now, at this point, you can even stop proceeding with the calculation, because you know that the frequency is 6 Hz. So we move on to the next one. We have speed. The other one is 4 centimeters over 4 centimeters per second over 2. The answer is 2. This is wrong. We go to the next one. Frequency is speed is 10 over 30. The answer is 0. As you move, you even stop, because the frequency is 6. What about this one? Speed is 12 over 2. The frequency is 6 Hz. So the answer is where we have these values. And where do we find them? On option D. So the answer is D. Question 8, the answer is D. We move on to question 9. Sound waves are being produced by radio, loudspeakers, industrial machines, and children in a playground. These sound waves have the same. What do they have in common? Okay, well, they have the same speed, because they travel at the same speed in air. Sound travel, there is a speed of sound in air, so they have the same what? The same speed. So the answer is C. We move on to question 10. Question 10, the diagram shows reflection when light rays strike a rough surface. We need to know what type of reflection is here. Well, the question is even asking what kind of reflection is represented in the diagram. Well, it's diffuse, okay? It's diffuse. It's not angular, it's not parallel, it's not transparent, but diffuse, or smooth, no, but diffuse. So the answer for question 10 is B. We move on to question 11. The diagram shows a boy standing 3 meters away. This question, we need to be smart in the way we are going to deal with it. This diagram shows a boy standing 3 meters away from a plane mirror. Okay, so we have this boy who is standing 3 meters. So we have these meters here. We have from here 1 meter, 2. So we have 1, 2, 3. So this boy is standing here. Okay. He is standing here, which is 3 meters. That's what the question is saying. And we must know that even the image is 3 meters away. This is the object, the image is here, and the boy is also standing on the image 3 meters away from the mirror. Meaning the distance from the boy to the mirror is 6 meters. The distance from the object, which is the boy, to the image in the mirror or behind the mirror is basically 6 meters. Okay, he then moves 1 meter closer to the mirror, meaning he moves from 3 meters to 2 meters away from the mirror. The image will also move to this point at 2 meters away from the mirror. So now the question is, how far is he from his image? Not how far is he from the mirror. We know that he's 2 meters away, but from his image. So meaning that the image had also moved 2 meters closer to the mirror, meaning that the distance is the sum of this, which is 4 meters. I hope I'm making sense. So the answer is C. Question 11, the answer is C. We move on to question 12. Question 12. Which of the following is a characteristic of an image formed by a plane mirror? You should know from grade 9 level that it's virtual. Okay, so the answer for question 12 is D. Question 12, the answer is D. Question 13. Which of the following best compares the magnetic properties of iron and steel? Well, you need to know that iron is easy to magnetize, steel is difficult to magnetize. Iron can form a temporal magnet, steel can form a permanent magnet. So we go to the options, okay? Difficult to magnetize, steel, difficult to magnetize, wrong. Difficult to magnetize, easy to magnetize is actually the opposite. Easy to magnetize makes temporal magnets. These two properties are for iron. D makes temporal magnet difficult to magnetize. It is true. The answer for question 13 is D. Okay, we move on to question 14. Question 14 says the diagram shows two metal spheres R and S touching each other placed on a insulating stand. A negatively charged polythene rod is held near the sphere to separate the metal spheres. Okay, so now what are we talking about here? We have these metal spheres. They are touching each other like that. So they have not drawn to actual scale or actual representation, but I hope you understand. This is R, this is S. So now, because they are touching each other, you need to identify the charges the way they are, especially when a negatively charged rod is brought near. What you need to understand is that the positively charged will remain this side, okay, and the negatively charged will accumulate on the sphere S. Are you getting that? So that when they are separated, this is what you are going to have. This is R, this is S, and this will be positively charged. Remember, like charges do what? Repel. Wow. Opposite charges attract because there is a negatively charged rod here, which will cause these to attract. So which one is the answer here? Well, we are told that R positive, this one already, this R is negative, this one is positive. No, R will be positive. Yes, R will be positive, and then S will be negative. The answer is C. Question 14, the answer is C. We move on to question 15. We're almost done with section A. A battery moves a charge of 70 coulombs around a circuit at a constant rate of 1 minute. So here you need to be able to come up with the data. One thing I'll tell you with physics is that it is important, it is of great importance to make sure that you extract the data from the question so that you know where you are going, and it will be able for you to extract the formula that they are looking for. So in this case, when we write our data, we are told that a battery moves a charge of 70 coulombs. So we have charge, which is 70 coulombs. What else do we have? Time, which is 1 minute. But 1 minute, remember the SI unit for time is seconds, so this is 60 seconds. What is the question looking for? Current. What is current? We don't know. So we need to come up with a formula. Okay? Remember, current is basically the rate of flow of charge. Okay? So current is the rate of flow of charge. So if we are asked to find current, this is the formula that we are supposed to do it to use. What is charge? Charge is 70 coulombs, and what is time? That is 60 seconds. So if we use our calculator to say 70 divided by 60, that would be 1.16, which would be 1.17. If we were to round it off to one decimal place, this will be 1.7 coulomb per second, which is basically equal to 1.7 amps current. Okay, so we look for that answer. I beg your pardon, this is not 1.17 but 1.7, but 1.1 So not this, but 1.166, which is the same as 1.2 or 1.17, because we are being guided by what is on the question. I had made a mistake here, I had left a 1 here. So the answer should be D. Okay? So question 16, is it 15? The answer is D. Yes, the answer is D. We move on to question 16. Two resistors of 12 and 24 ohms are arranged in parallel. You've seen this, right? And we are told that a 4 amp current flows through a 12 ohm resistor. Okay, so now here is the situation. We've got a situation to digest here and be able to come up with the answer. So we have a situation like this. We have the 12 ohm this side, and then we have a junction here, then we have a 24 ohm resistor like so. We have a junction here. I've not drawn this to the way it's appearing, but I will be able to relate. So this is 24 ohm, this is 12 ohm. So now we are told that there is a 4 amp current flowing here. This is Y, this is X, and this is A. Probably we don't know what A is, because the question is saying what is the reading of current on the ammeter A. So this is what you need to know. Current will always flow where there is less resistance. Most of the current will flow where there is less resistance. Okay? So how it is here is that you have this current, this resistance, which is 12 ohm, and this one, which is 24. So if 4 amps can flow where there is 12 ohms, then half of this will flow where there is double of this. Are you getting that? So it's like a ratio. There is inverse proportionality there. Okay? So we are saying that the more resistance is, the less current that will flow. Are you getting the sense there? So in this case, the ratio here is 1 to 2. And then you've been told that the 4 amps is flowing this side. What will flow this side if the ratio is inverse? You need to know that half of this is what will flow here, which is 2 amps. I hope you are getting that. Because let me give you this illustration. If you have 2 ways, okay, you have 2 ways, but if you have one route, you are all moving to a certain destination. But you've been told that there's a junction, and then this side, route A, this is route A, and then this is route B. Now you've been told that there is a checkpoint here, and this checkpoint is not only one, there are 3 checkpoints which are there. And this side, there's only one checkpoint, okay? Now, as a normal driver, which route would you use, okay? I know a normal one would say, I'm going to use the route where there is less congestion. Because these checkpoints, you know that they are creating congestion here, and it will be difficult for the cars to easily pass. Hence, time will be consumed just trying to negotiate and be able to pass. But when it comes to this one where there is one checkpoint, there is less congestion. So current behaves the same way. It would not want, if I were to represent checkpoint with, to say checkpoint represents resistance, because basically resistance is the opposition to flow of current. So meaning that this, if you represented resistance, it means that current would not want to flow this side easily, but it would want to flow where there is less resistance. Are you getting that? So meaning that more vehicles would pass this side, just like more current would flow where there is less resistance. I hope you are getting that. So now, what is the answer here? Well, the understanding is that this side there will be 2 amps. 2 amps flowing this side. Okay? that would be there. Now, what would be the current here? Well, the total current would be basically, remember we're not finding the total resistance where we are using that formula, but we are finding the total current, which is just basically the sum. So it would be 6 amps, the current here. So the answer would be B for question 16. The answer would be B. We move on to question 17. Question 17. Well, the question reads as follows. The question reads saying that the diagram shows a coil in a magnetic field. There are permanent magnets in the south and north. When the coil forms part of a DC motor, this coil, what must be connected to J and K? So there is also what we call an AC generator. There's an AC generator, there's an AC motor, DC generator, there's a motor, and all those things. So now, when it comes to AC, what is connected here, okay? What is basically connected here when it comes to AC are the slip rings. AC, it is slip rings. But when it comes to DC, we have what we call split rings. Please note that DC, split rings, AC, slip rings. I hope you'll be able to remember that. There is a topic that we need to basically do to address this part, because mostly it confuses DC and AC generator. I think there's a question I saw which is 2023 science paper 1. I'll be able to address that question in order to make a good tutorial that will be beneficial to anyone who has some doubts on this part. So the answer for question 17 is D, which is the split ring for DC. So the answer is D. We move on to question 18. A transformer needs to convert a mains 240 volts supply into a 6 volt supply. If there are 1000 turns on the primary, how many turns should be there on the secondary coil? So as usual, we need to come up with the data. Okay, what data can we obtain from this question? Okay, well, when we write our data, we need to know that, let's read the question again. A transformer is needed to convert a mains 240 supply into a 6 volt. So this is secondary, this is primary. Why am I saying so? Because there is a guide here that if there are 1000 turns on the primary, how many turns should be there on the secondary for you to have a conversion of to 6 volts. So we need to write the data. What data can we write? We have voltage on the primary, voltage on the secondary, number of turns on the primary, and number of turns on the secondary. What are those values? Voltage on the primary, we have 240 volts. Voltage on the secondary, we need to convert this 240 volts to 6 volts. The number of turns on the primary, we're told that there are 1000. What about number of turns on the secondary? We do not know. So from there, we need to come up with a formula. So the formula is going to be Vp, voltage on the primary, over voltage on the secondary, is equal to number of turns on the primary over number of turns on the secondary. What are the number of voltage on the primary? We have 240 over voltage on the secondary, 6 volts. Number of turns on the primary, we are told that it's 1000 over number of turns on the secondary. So here the formula is going to be number of turns on the secondary is equal to 6 multiplied by 1000 divided by 240. So we have 600 over 24. In fact, 6 here, 6 into 24, it's 4. Then you have 6 into 10, 6 into 10. So we write it here, 4 into 100 is equal to 25. So we have 25 tens on the secondary. Do we have 25 tens on the secondary? Yes, the answer for question 18 is what? It is A. The answer for question 18 is A. We move on to question 19. Question 19 says, radon decays to polonium by emission of alpha particles as shown by the following decay equation. Okay, so we have this decay equation with us here, and we are told that radon decays to polonium. So now remember, it emits an alpha particle or alpha particles. So what are the values of P and Q? There is an equation that you should be aware of. Okay, this equation goes like this: x plus the alpha particle to give us not this necessarily, but we have x, okay, where we have a minus 4, and then we have z minus 2, then this one decays to y, okay, which is plus the helium particle. Okay, yeah. So now what this means is that we need to subtract this from this. Let me rewrite it again. This is gonna be x a z to give us y a minus 4 z minus 2. Exactly. I think this one now makes sense. You know, this is 4 2. I'm doing this in a live way. Okay, like there's nothing like going through the question before doing this. So as I'm doing this, it doesn't make sense, I'll be able to correct it. So now here what you need to know is that you need to subtract, because in chemistry there is no minus, you can't put minus, and whenever you see this you need to know that this is decomposition reaction basically taking place, and we need to make sure that we understand that this was subtracted from this. That's why there is this denotation here. So what are we going to do? We come here. What is the equation saying? We are told that there's 218 here, meaning the number, there is a number here from where this 4 was subtracted for us to get 218. And also 2 was subtracted from this Q to get 84. So that is simple mathematics. What it means, you have to add 4 to this and 2 to this. I believe that Rn will have 218 plus 4, it gives you 222. So there is 222 here. Then 84 plus 2 gives you 86. So there is 86 here. That's what it means, because this decayed to polonium, which has 218 because you've subtracted the 4 from there, and also 84 because you've subtracted 2. Where are you getting this? Because an alpha particle basically is a helium atom. Okay, a helium nucleus, let me say that way, a helium nucleus. Okay, so this is what you subtracted from here for you to get this. That's what it means. I hope you're able to get the concept there. So the answer is for question 19 is D. The answer for question 19 is D. We look at the last question. An industry buys 200 grams of radioactive sample with half-life of 5 years. How much of the radioactive sample will remain after 20 years? Here is another question which requires a lot of thinking per se. And we are told that the initial mass that was bought is 200, okay? But we are told that the half-life is 5 years. So half-life is 5 years. 5 years, okay? That's the half-life, meaning that after 5 years, this one would reduce to half. So what it means is that it took 5 years for this to reduce to 100. It took another 5. It takes 5 years for this to reduce to this. It takes another 5 years for this to reduce to 50. It takes another 5 years for this to reduce to 25, it takes another 5 years. For this to reduce to 12.5, it takes another 5 years for this to reduce to 6.25, 5 years. Now, we are asked to say, wow, how much of this will remain after 20 years? So we're just going to say 5 plus 5, that's 10 plus 5, 15 plus 5, that gives us 20. So now this 20, you are going to find what remained after 25, 10, 15, 20 years. The answer is 12.5. Do we have 12.5? Yes. The answer for question 20 is A. The answer for question 20 is A. Well, candidates, colleagues, learners, pupils, I hope this video has been so helpful to you and you've been able to follow and be able to get what is meaningful for you, even as you leave comments in the comment section. And I hope this has been helpful. Bye-bye.